2.3, we're talking about multiplying and dividing rational expressions by simplifying. Okay, so if I look at these examples that you have, okay, I want to look at example 2a is what I'm on. So 2a, I have x squared plus 2x plus 1 over x cubed minus 2x squared minus 3x. It wants us to simplify each expression. When we simplify rational expressions, again, what I mean by rational is they're in fraction form. Okay, we have a numerator and we have a denominator. What does numerator mean? The top. Denominator means the bottom. Okay, when we're simplifying, we're going to look at the numerator and the denominator as separate pieces. Okay, so looking at the numerator, I want to simplify the numerator as far as I possibly can. Okay, so what that means is we're probably going to have to factor. Okay, so looking at the numerator, my x squared plus 2x plus 1, I want to find factors of 1. What are factors of 1? 1 and 1, right? Will 1 and 1 get us to add up to 2? Yep, so how do I write that since those work? X plus 1 and x plus 1. Do you agree that's simplified as far as it can go? Okay, we can't factor anything else. We're not setting anything equal to 0. Okay, we're just simplifying. Okay, so the numerator is done and it's factored. Now we do the same thing with the denominator. Before I can factor the denominator, always see if you can take something out. Can I take anything out? I can take an x out because they all have an x in common. So taking out an x, I'm left with x squared minus 2x minus 3. Is the denominator factored all the way, or is it simplified all the way? Is it factored all the way or simplified all the way? No. Usually whenever you see an x squared, you can probably go farther. Okay, we can factor again. So again, our numerator is done, so I'm just going to rewrite the numerator. And then our denominator, we still have this x here. Okay, we don't want to get rid of that. We're going to keep that. We still have the x. Okay, now I want to factor our x squared minus 2x minus 3. Okay, I'm going to factor this part right here. So what are factors of 3? 1 and 3. How can we get 1 and 3 to get to negative 2? Negative 3, right? So if I rewrite this, I have x plus 1 and x minus 3. Now, do you agree that both the numerator and the denominator are both factored completely? Yes. Okay, they're both in simplest form right now. Now, once we have each of them factored completely, we want to simplify together. Okay, what's going to happen is we can start canceling some things off, whatever the top has compared to the bottom. Okay, what do you notice between the top and the bottom? What do they have in common?
Same degree.
Think of their pieces. So on the top we have x plus 1. Does the bottom have an x plus 1?
Yeah.
Yes. Okay, what is it? Okay, if I divide, for example, 2 divided by 2, what's that?
Cancel.
2 divided by 2 cancels, because it equals 1, right? So do you agree that x plus 1 can cancel?
Yeah.
Yes. Okay. Can I cancel this one? No. Okay, you can only cancel out 1. 1 cancels out 1. 1 cannot cancel out 2. Okay. Do they have anything else in common? No. They don't, right? So our answer is just whatever they have left.
What's x plus 1 over x minus 2?
Yep, so the top has x plus 1 left. The bottom, don't forget this x over here. Okay, it still has x times x minus 3. And then this right here is your answer. What'd you say?
Do we set them equal to 0?
You do not set them equal to 0. This one just wants us to simplify.
Is this all we're doing?
Yep, today. This is all it wants you to do. If it said solve, that would be a different story. Okay, but all of this is going to say so far is simplifying. Okay, so that's all the farther you go as long as you have nothing else to cancel out.
Are we going to be solving it though?
I want to look at that example 2b. Okay, I'm going to change it a little bit to make it nicer. Okay, so your example 2b, we're going to change it a little bit. Okay, it's going to turn into x squared plus 4x plus 4 over x squared plus 3x minus 4. So again, we have our rational expression. We want to simplify. How do I simplify? Do we simplify all at once?
No.
We look at one and then the other. So let's look at the numerator. We have an x squared, so that means we're probably going to have to factor. Okay, so factors of 4. What are factors of 4? 1 and 4 and 2 and 2. What is going to get us to add up to 4? 2 and 2. Do I need to change them? No. So how do I rewrite that? X plus 2 times x plus 2.
So what happens with the 4 and the other 4?
We're factored. Just like normal, this factors. Because if I go backwards and I multiply all of this, it would get me back to what I started. Yep. So now we're moving on to the denominator now that we're done simplifying the numerator. So with the denominator, we see that there's an x squared, so we're going to factor. Okay, so again, do you agree we're looking for factors of 4? Okay, we already have them. What is going to add us up to 3? 1 and 4. Do I need to change them?
Yeah.
Which one?
-1.
Change it to a -1. So that turns into what? X minus 1. X plus 4. Do you agree both the numerator and the denominator are simplified?
Yeah.
Yep. So what is kind of our step 3? Going to start canceling some things out. Does anything cancel out?
No.
I'm going to ask you something.
No.
Why can I not do this?
It's on the same row.
Because they're on the same row, okay? Remember, we can only cancel out top to bottom, okay? So I cannot cancel out the x plus 2's. Can I cancel anything out?
No, but can you simplify the 2 and the 4?
You cannot. Good question. She asked if I can simplify the 2 and the 4. I cannot because they're enclosed in those parentheses, okay? Because this 2 is with x plus 2, this 4 is with x plus 4.
So no.
Okay, so you cannot. If there was a 2 and a 4 on the outside, yes, you could simplify those. Okay. So can I simplify anything? No. So this right here is just my answer. So looking at this one here, we want to simplify the numerator and then simplify the denominator and then compare the two. Okay, so looking at the numerator, we have an x squared, so that means we're probably going to have to factor. Okay, so what are factors of 4?
1 and 4.
1 and 4?
2 and 2.
2 and 2. What pair is going to add up to 5?
1 and 4.
1 and 4. Do I have to change them?
No.
No. How do I write it? X plus 1, x plus 4. Are we done with the numerator? Yes. Moving on to the denominator, we have an x squared, so I'm probably going to factor. What are factors of 2?
1 and 2.
1 and 2. How are we going to get that to add up to, what's the coefficient here? 1. Yep. How are we going to get that to add up to 1?
-1.
Yep. So that turns into x minus 1 and
Times x plus 2.
x plus 2. Okay, are we done simplifying?
Why did we not keep the other x?
Okay, so now we're on to step 3. Now we can start canceling things out. I'm going to ask you, can these two cancel each other out?
No.
Why not?
Because they're not the same.
They're not the exact same. If it could cancel out, this would have to be a plus 1, or this one would have to be a minus 1. They have to be the exact same. Okay? So can anything cancel out? No, so what's my answer? Right, whatever we're left with. Okay, that's our answer. Okay, let's look at example 3. Now we're going to get into multiplying and dividing. Do not worry, it is the exact same thing as what we just did, and I'll explain why. Okay, so looking at example 3a, we have x squared minus 16 over, I'm going to change that to x minus 9. Go ahead and change that. Okay, I changed it to x minus 9 times x squared plus x minus 90 over x squared plus 14x plus 40. What do you notice about this example compared to ones we were just looking at?
You have to multiply.
There's two different expressions, right? We have to multiply. You are going to solve it the same exact way as what you just did. Okay? So we started simplifying the numerator and denominator. You just have to do that for each expression. Okay? So I'm first going to start with this rational expression right here. So starting with their numerator, okay? remember, these are both perfect squares, yes? Meaning, what can I multiply by itself to get x squared? What can I multiply by itself to get x squared? X, right? So I know we have x here. What can I multiply by itself to get 16? 4, right? So this turns into x plus 4 and x minus 4. So moving on to the denominator now. Can I do anything with x minus 9?
No.
No. So I'm just going to keep x minus 9 how it is. Do you agree I'm done with that fraction?
Yep.
Yep. So let's move on to the second fraction. We're going to do the same thing. Notice we have an x squared, so what are we going to do?
Factor
We're
90.
going to factor. Factors of 90. We are not going to write all these down, but think, what are factors of 90 that are going to add up to 1? 10 and 9. Yep. So we have 10 and 9. Which one of those do I need to change to get to 1? The 9, right? 9 needs to become negative. How do I write that?
X plus 10 times x minus 9.
Good. Are we done with the numerator?
Yep.
Yes. Moving on to the denominator, we have an x squared, so what does that mean we're going to do? We're going to factor. Factors of 40, that'll get you to 10. Or sorry, to 14.
4 and 10.
4 and 10. Do I need to change either of them?
No.
Nope. What does it turn into?
X plus 4 times x plus 10.
X plus 4 times x plus 10. Okay, right. So what was our normal step 3? Canceling things out. Okay, understand this is multiplying, right? So when we multiply fractions, remember we just think multiplying across. So do you agree that this is just going to turn into one big fraction
Yeah.
if I multiply it across? Okay, so the multiplying step doesn't really change anything. So it turned into one big fraction, so we can do what we've been doing the whole time. We can start canceling things out. What do the top numerator and the bottom denominator have in common?
X plus
X
4.
plus 4.
I agree with x plus 4, so I can cancel those out. What else?
X plus 10.
I agree with x plus 10.
Can we do x minus 9?
We can. Yep. And we can take out x minus 9.
So then we just have x minus 4.
Right, so now write what we have left. What's left on the top? X minus 4. What's left on the bottom? Nothing. So it's not 0, remember? It's just turns into 1. Okay, but do we have to write the 1? No. So our answer is just x minus 4. You can if you want, you don't have to. Yep. So what I want you to understand is, do you understand that multiplying is the same thing as what we were doing before?
Yeah.
Okay? It's just with multiple different fractions. So that multiplication sign, I want you to think it just turns into one big fraction. Okay? It just combines. Let's look at example B. What do you notice about example B? There's 3 of them. Does that matter? Nope, you're still going to do it the same way. You just have more to work with, okay? So as I'm rewriting this, think, how do we solve these? Do I look at it all at once?
No.
No, look at them separately. So I'm going to look at that left fraction here. I'm going to simplify. Can I do anything with x plus 3?
No.
Nope, so I'm just going to leave it. Can I do anything with 4x?
No.
Nope, so I'm just going to leave it. Do you agree I'm done with the first one?
Yeah.
Yes. Looking at the second one, can I do anything with 3x minus 18?
Take 3 out.
Take out a 3. Yep. See what they have in common, take it out. If I take out a 3, what's left?
X.
X minus, yep, 18 divided by 3 is 6. Do you agree I'm done with that one? Okay, same thing, 6x plus 18. Can I take anything out?
6.
A 6, so what am I left with?
X plus 3.
X plus 3.
Oh, that cancels out. Oh, no, it doesn't.
Moving on to the last one. Can I do anything with x squared? No. Can I do anything with 4x plus 12?
Yeah.
What?
Take out 4.
Take out a 4. If I take out a 4, what's left?
X plus 3.
X plus 3. Am I done with the problem?
Yeah. You're simplifying.
Now we're at the fun step, right? With that multiplication, what happens? Turns into one big fraction. Okay, so we can start canceling some things out. But remember, when you cancel things out, it has to be top to bottom. Okay, so what are some things that cancel out?
Can you do the x plus 3?
Yep. So we have this x plus 3. Can I cancel out both of these?
No.
Nope, only one of them. Does it matter which one?
No.
Doesn't matter. Is there anything else we can cancel out?
Yes. No.
Okay, let's rewrite with what we have left. What do we have left on the top?
3 times x minus 6 times x.
Yep, I'm just going to write that as 3x squared times x minus 6. Divided by what's left on the bottom.
4.
We have 4x and 6 and 4 and x plus 3. What do you think we should do with all of these coefficients? We're going to multiply them together. So 4 times 6 times 4, that gives you 96. We still have this x. Do you agree? Okay. What else do we have still? X plus 3. Okay, looking at what we have right now, do you think we're done or is there more we can cancel out?
One of the x's.
Right. We have these x's here. How many x's are on the top?
2.
2. How many are on the bottom? 1. So how many can cancel out? One of them. So take out one of them. There is one more thing.
The 3 and the 96.
The whole number is out in front, right? 3 and 96. 3 goes into both of those. How many times does 3 go into 3?
1.
1. How many times does 3 go into 96?
32.
32. So now let's rewrite what we have left. What's left on the top? 1x times x minus 6 over 32 x plus 3. Now are we fully simplified? Yes. Okay. Now, I understand that was a huge problem, but that was a very good example to see all of the different things that you can cancel out. Okay. You could have done all of that canceling out up at the top. Okay, understand that. But it is okay to simplify and then see, oh, I have whole numbers or I have extra x's that I can cancel out. Okay. Last one I want to look at today, and that is example 4b. We're not going to do A. 4b. So I have 3x squared plus 6x over x squared minus 49 times, what's that going to turn into? That x squared plus 9x plus 14, is that my numerator or my denominator? It's the numerator because what can I technically put underneath it? A 1. Yep. Good. How do I solve this if the directions say simplify?
You can cancel the x squared.
Not yet. I can't start canceling yet. What do I have to do first?
Factor.
I have to factor first. Canceling out is all the way at the end. Okay, so look at them separately. What can I do with 3x squared plus 6x?
You can take out a 3x.
I can take out a 3x. What's left if I take out a 3x? X plus 2. Okay, remember this bottom one, I have a perfect squares. Okay, what's the square root of 49? So we have, this turns into x plus 7. This turns into x minus 7. Do you agree that we're done with that first one? Yep, so moving on to the next fraction. We have an x squared, so we're probably going to factor. What are factors of 14? 1 and 14? 2 and 7. What's going to get us to add up to 9? Does everyone agree?
Yep.
How do I write that? X plus 2. X plus 7. What's on the bottom? Can I do anything with 1? Nope, so it just stays as 1. What operation's happening? Multiplication, so what happens? Turns into one big fraction. Now we're at the cancellation step. What cancels?
X plus 7.
X plus 7. Does this x minus 7 cancel?
No.
Nope. Can I cancel these two?
No.
Why not?
They're not.
Right, they're on the same level. They have to be top to bottom to cancel out. Can I take anything else out?
Can you simplify the 3 and the 1?
I could, so do you agree like this one's gone?
Yeah.
Is that what you're saying? Yep, because 3 divided by 1 is just 3. Okay. Can I take anything else out? Nope. So what's left on the top?
3x.
3x times x plus 2 squared.
Yep. So what she did, this is what we had left, right?
Yeah.
But what's a different way I can write this?
Squared.
Yep, two of the same thing. You do not have to do that though. You can if you want. Okay. Over what's on the bottom? X minus 7. Done. That's your answer. Yep. So, biggest thing, remember, you need to simplify first before you can start canceling things out. Canceling out is the last thing you're going to do. You have to simplify first.